I'm live. I assume I am. So I am here today to do some nth term of sequences. This is not something that is tough, but if you go into it assuming you're going to struggle or thinking negative things about algebra or negative things about yourself, you're going to find it harder than if you just go in going, okay, we'll see what you've done. Now you'll notice there was a picture of a tortoise on the front of the slide. This is because Mr. Harris has taught us this before. Way back we did some nth term right at the start, but I don't remember which lesson it was, but I thought there's no harm in doing some more. What I'm going to talk to you about is the fact that the nth term is like a special machine that pumps out sequences, and if you are careful with it, you can use it to both say what the sequence was once you've got a sequence, to say what the generator was, or to generate sequences in the first place. So let's get on with it. Okay, alrighty then. We're going to go straight into the whiteboard today. And on the whiteboard, I have got some sequences. By the end of today's lesson, we're going to know how to find nth terms of these sequences, because they've all been generated in a certain way. But in order to do so, we're going to briefly talk about what's going on. What's going on? What's going on? I don't know why I'm singing. So, let's rearrange my mouse so that that works. We are going to look at, if you've got a machine that spits out sequences, it's going to have some inputs. And the inputs, if you imagine a flow of water, but this is not normal water, this is number water. Therefore, it delivers a 1, then a 2, then a 3, then a 4. This water we're going to call n. It's like the number that's coming in. The number that's flowing into the pipes has a machine that happens to it to flow out different outputs. And each input will give us a different output. So let's say we wanted to do times by 3 and add 4. Well, then what we're going to do is we're going to take the 1 times 3, add 4 is 7. 2 times 3 is 6, add 4 is 10. 3 times 3, add 4 is 13. 4 times 3, add 4 is 16. However, in algebra, because the number that's flowing in is the n, and we think about this n flowing in each time, we can, by using n, we can say, well, what would the formula be for any number? And it would be 3n plus 4. Whatever number comes in, we times it by 3 and add 4. We can use this to generate any sequence we want. For example, we've got a new sequence, which means the outputs change, but the inputs are always 1, 2, 3, 4. And it could be 5, 6, 7, 8, 9, etc, etc, etc. But we're going to say, well, what about if we've got 2n plus 5? What we do is we take the 1, times it by 2, so we've got, this would give us 2 times 1 plus 5. Now, last week's lesson was on substitution, so this is all very similar. You can see it's all substituting numbers in to see what we get out. 2 times 1 is 2, add 5 is 7. 2 times 2 is 4, add 5 is 9. 11 and 13. Now, hopefully you notice something. These have got a gap of 2. They are the 2 times table, and it's because of this. The 2n will tell you what the gap is. If it was 3n, the gap would be 3. Now, let me just say a quick hello, good morning to Summer, good morning to Eddie, good morning to Adeline, good morning to Aaron, good morning to Ellis, good morning to William, good morning to anyone else. Anyone else. Okay, now, we're going to do another one of these. I'm going to give you a chance to pause or just say in the live chat what you think the outputs should be. So I'm going to change my inputs. We've got a new machine. The new machine is 5n minus 1. Write down what 4 outputs you think you're going to get. Okay. Hi, Sebastian. Absolutely, Adeline. If it was 100n, there would be a gap of 100 between each term. You're absolutely spot on and you're understanding it. So what would these numbers be? I'll give you a hint in anyone who's just trying to get their heads around it. I think 5 times 1 is 5. Take away 1 is 4. Another way of thinking about it is it's the 5 times table, 5, 10, 15, 20, is called 5n. Therefore, 5n minus 1 is take 1 away from each of these numbers. So well done if you got 4, 9, 14 and 19. Good afternoon, Claire and William. So 4, 9, well done Adeline, that's excellent work. So we've got the outputs come from doing the 5 times table, take away 1. 5 times 1, 5 times 2, 5 times 3. We can keep up with this idea. Sometimes we might have even 2.5n plus 3. I'm not expecting year 5s and 6 to be able to come across these. This is like year 8 or 9, but no harm done. The 2.5 times table is 2.5, 5, 7.5, 10. So we're going to have add 3, add 3, add 3. We've actually got, hopefully, 5.5 is our first exit, first output, 8. And as Adeline's been pointing out to us, that means the gap is going to be 2.5 between all these numbers. And it is. The gap is 2.5. So this is how you generate sequences to start off with. You start with 1, 2, 3, 4. Always start with 1, 2, 3, 4. However, what we had here, it was asking us, here's the outputs. What was the rule? So what was the machine? But what we need to do is think backwards. Now, when I say think backwards, I don't mean I'm going to think like this. I mean we're going to need to think, well, if we know what the outputs are, what can we do to help us? So using this machine, what could we do with this first question, 2, 4, 6, 8, 10? We now know the outputs are 2, 4, 6, 8. And what it all boils down to, thinking about what Adeline was saying about the gap tells us which times table it is. So what we do is we look at our outputs and say, well, the times table is 2, so it's 2n. It's as straightforward as that. We look at the gap and think about how many n it's going to be. Then we do an adjustment, maybe. But let's check. Let's see what 2n is. We write down 2n is 2, 4, 6, 8. And we want 2, 4, 6, 8. So it's just 2n. In this one, it would just be 2n. Let's go up and write that one down. However, if we go to the 4, 9, 14, 19 one, I want one that's going to be a bit different, you see. Rub everything out. And these are the steps. The outputs were 4, 9, 14, 19. So we do what Adeline was saying. We find the gaps, which are 5, 5, 5. That tells us it's 5n. But the problem is, the 5 times table is 5, 10, 15, 20. And we haven't got 5, 10, 15, 20. We've got 4, 9, 14, 19. In fact, all of these have had 1 taken away. And that is the reason Adeline is telling us in the chat it's 5n minus 1. Because it's 5 goes down 1 to 4, 10 goes down 1 to 9, so it's 5n minus 1. Okay, so each time, and we go back to where we were doing the questions, 5n minus 1. Let's stay on the same page now and choose a random one. What about this one here? Number 7. Well, we've got the numbers. We've got to do something to get, and I'm going to now do it on the actual numbers themselves. The gaps are 2. That tells us it must have 2n in it. But then the 2 times table is 2, 4, 6, 8. And we want 9, 11, 13, 17. So we have to add 7. So it's 2n plus 7. We can do this for each of them. And hopefully there'll be more people agreeing with Adeline. It's not too hard, this. It looks like it's going to be super hard, but it's just finding out the equations. And we can do this for all of them. feel free to pause the video now if you don't want to hear the answers, because I'm going to do each of these now, and hopefully it will make some sense to people, but you can pause and have a go at them first. I know some of you will like to have a go before Mr. Harris has a go. So let's quickly do this with a slightly smaller pen. There we go. So we've got a gap of 3. The gap of 3 tells us it's 3n. The 3n is 369. It is 369, so that one's correct. The gap, find the gap. Just like at the underground when it's mind the gap. 6n. Well, the 6 times table is 6, 12. It is exactly what we want, so it's done. This is the first one where it's going to be slightly different. Let me rub out those 6 and 12. Uh-oh. The gap is 2, but the 2 times table is 2, 4, 6. 2, 4, 6, 8. We want 3, 5, 7, 9, so we have to add 1. Always look from the times table. This is 2n, so this is 2n plus 1. So we're going to have 2n plus 1 here. This gap, find the gap, and the gap is 7, 7, 7, 7. Then once we've found the gap, it's going to be 7n. That we then write the 7 times table, 7, 14, 21, 28, ... But we want 8, 15. We don't want those first numbers, we want the second numbers. So we're going to go, that is 7n, so this has been added 1. So it's 7n plus 1. We've now got 3 more to do, and so the next one is, find the gaps, it's 2, but the 2 times table is 2, 4, 6. We don't want 2, 4, 6. Oh, we don't want 2, 4, 6, 8. We want 6, 8, 10, 12. So it's plus 4. So that would be 2n plus 4. This one has got a gap of 4, 4, 4, 4. So it must be 4n. But it's not 4n because 4, 8, 12, 16. We've got 5, 9, 13, 17. So we need to go up 1 again. 4n plus 1. And the last one has a gap of 3, 3, 3, 3. So it must be 3n. But normally the 3 times table is 3, 6, 9, 12. So it must be take away 5. Because we don't want to start at 8. We want to start at 3. So we have to take away 5 to get there. And that is how you find the nth term of sequences. I hope this has made sense. By doing 10 of them, I'm hoping you can follow through them, and if you are understanding it, you can then carry on. There's a worksheet in the description below. If you're not, go back and watch how I do it again. I know this is for year 5s and 6s. This is all maybe some new stuff, but it's also up to year 9, so all the way through. If you can practice this skill and get good at it, it's called the nth term of sequences. It's not algebra, it's just how we describe sequences. Sequences are all described in a little term with n. Remember, if we're going the other way, you use that time. So let's say I'm doing 5n minus 1. I use the 5 times table, 5, 10, 15, 20, and then take away 1 from them. And that's all there is to do today. That is a short 15-minute video on using the nth term. I hope it's been useful. I've been Mr. Harris. You haven't. Look after yourselves and take care. Bye-bye.